Still some 30, 34, 35 students are there, including some visitors also, right? I think student participation is maybe even less than 30. Okay, let's start. Otherwise, as usual, before I start, do you have any questions? I think we are meeting after 2 or maybe 3 weeks of lapse like a break. Do you have some questions to ask? How many of you are able to practice? Please raise your hand. Those who practice during the last 2 weeks, can you please raise your hand? Only 6 out of 100 to 120. Okay, still coming up.
Sir, there is a misunderstanding. So some of nearly 30 or 40 students have joined the comment discussion meeting.
Yeah.
I'll convey the message and let them ask them to join this meeting quickly.
Okay, sure. I'll wait for a few more minutes. Just discussion, right? Ask them to join the quickly. So as usual, if you are not practicing, if you are not asking questions, if you are not clarifying your doubts, you might find it difficult, right? I think we have tried this model except the last one. I asked you to model and send me. I think only few students have sent the model, and that's again in a student version. I'm right now at the office. I can't open them in the office because I don't have the student version, but at home I have it. Maybe I will try to give you some comments on those things, and also I will show you how I model this particular part, the last one in the bottom right hand corner. And the first model that we have already, you can try to create that one as a synchronous model, and then maybe the other one also you can try to model them as what you call the synchronous parts, right? Maybe before I start the modeling, I will go through some questions and also some more modeling tools, right? Still some students are joining. I will wait a few more minutes. If you find it difficult, maybe you can just postpone the synchronous modeling and then you can concentrate only on the ordered modeling. So if you don't find any other option, but you have to start with the ordered modeling. So you can find some similarities with maybe even SolidWorks or Inventor. So then it will be easy for you to follow the ordered modeling and then you can move on to synchronous modeling. But remember, don't mix them up, right? Don't mix them up. So more students are joining. I just okay. Let me show you this. The first part that we have tried in ordered modeling. This is the synchronous way to model this one. Right. So what is the difference? We can see here some dimensions are appearing in the 3D model itself. We can see these dimensions are already there. Right. And if you see this, the Pathfinder, there is something called the used sketches. You don't find that one in ordered modeling because sketches are associated with the features. Right. You cannot get rid of the sketches because they are linked already. And also the history, parent-child relationships, and everything is there in the ordered modeling. And this PMI is product manufacturing information. So straight away you can see the dimensions are there. Dimensions are there. I can straight away change these dimensions. Right. So if you see these sketches, you can see one sketch is like that. Something similar to what we did in ordered modeling. And also the second part. And you can see a difference there. Second part is only two sides are there. The third side is not there. Right? You can do this in solid edge without any issue. Right? And then we have two protrusions. One is that, the other one is this. And you can see even some additional dialog boxes are coming up. These are what they call the design intent. And you can even get some more. You can see at the bottom of the screen, you can see there are some more. So that's why I told you maybe you can try the synchronous modeling bit later, right? Otherwise, if you have a free time, of course, then you can manage, right? And these PMIs also, you can see those dimensions are there. All these linear dimensions, you can click and highlight. You can define whatever the name that you want, maybe length, width, or whatever it is, so that you can easily identify them. Even this angular dimension is there. Whether it is synchronous or ordered modeling, remember you still need to maintain the design intentions. So that is what you saw earlier. When you click this one, this is a design intention. It's not that you are going to, apply all these things, but you are asking it to maintain this one when you modify this. Right? We'll see what these things are. Right? Now this sketch I used to what you call generate the first solid. In synchronous modeling, you can use the sketch as your starting point. But once you generate the 3D model, the sketch will be detached from the model. Right? So that is why it says used sketches. It's already used. If you want, I can reuse that one. I can activate it and then reuse that one, but there's no relationship between the sketch and the feature or the protrusion created. That is completely separated. So for example, I can right click here, I can delete, right? Delete, nothing happens, right? Because it is completely detached. That is why the difference between the ordered and the synchronous modeling. Ordered modeling, you always have to keep the sketches either as external sketches or as internal sketches. Right? So once you have that one, then you can control using, this the steering wheel is over there. Right? Steering wheel is over there. So for example, if I click on this face, right, and then maybe even if I click this again, you have this steering wheel. I can drag on this one, you see, and it maintains the symmetry. Can you see now? So in ordered modeling, you cannot do like this. Of course, to a certain extent, you can do it, and you can type the value over there. Right? So, for example, if it is 0, it will. You need to have a value because it's trying to change this one, change something. If I say something like say 5, for example, you maintain that one. Or else, if I remove this design intent, maybe only the symmetric design intent. Right? I remove only the symmetric design intent. And then if I drag it right now, you see now it is only one side. Right? Now it is only one side. Likewise, if you want, so because concentric is not applicable at this particular phase that I have selected, and 7 other things are not relevant, but they are all enabled. So you can cancel everything like this, or you can enable everything like this. So that is how the synchronous modeling is working. Right? Even this, I have only created 2 features like this. Now remember, in ordered modeling, you cannot change this order. You can do this one as long as there is no relationship. What sort of a relationship? We call the parent-child relationships. But here, if say this is the second part, right? Let me take it above the first part. You see now? That appears first. Other one is next, which is completely different when you compare it with the ordered modeling. Ordered modeling, you have to maintain. That is why they name it as ordered modeling. You have to maintain the order of feature creation, as long as you want to maintain the parent-child relationships. If you want to have a flexibility that you can move any feature anywhere, then you have to make them without relating to any of these things. But you can't do this one always. You can do to a certain extent, but somehow or the other, a feature should have some sort of a relationship with the other features as parent or maybe as a child or children. Right? But in synchronous modeling, it is not there. So you can just click on any face, and then you can click and then even rotate. You can even drag this face. You see now? And then if I, for example, if I select both faces, right? And then if I try to move this one, you can see it is moving only in one direction. Okay. You can even change the direction or whatever it is. This is what the flexibility that you get in what you call the synchronous modeling, right? And then the other part also, right? I think maybe this one. So you see, I have 2 parts created. This is the one that I gave you to practice without giving any dimensions. So here you see ordered modeling, and this one also, maybe I'll close this. I'll close that one to save memory, and then let me see. I don't want to save it. Right. Now this part and that part. You see ordered modeling and then another ordered modeling. You see the number of features here and you see the number of features there. Maybe almost similar. But if you see your base feature, Remember, in ordered modeling, we have the base feature. That is the base feature. How do I know that one? Maybe I can select that one, right click, and then say go to. This is how I started modeling that part. Right? How I started modeling that part. Maybe I remove this. Right, so that we can see only the feature. Right. Right. Now, if I go to the other part now, the other ordered part, I click and say go to. This is how I started. I remember I was telling this one, depending on the function of this particular part, you can change the base feature. Base feature is the most important thing. You attach all other features to the base feature. If base feature changes, then everything else will automatically update. And you cannot delete the base feature unless you remove all the features. So here, second part and then the first part, this is the base feature. And then what is next? Maybe I can right click and say again go to. So it will activate this one. You can see it is like that. The major features after that. Base feature is again one of the major features. And this is the other major feature. If you see the functionality of this one, that is how we identify. Right? And if you go to the, I will go simultaneously. And you see over here, that is the same thing. Right? And what you should maintain is you can see this edge is always vertical. Right? And that edge is also vertical. Right? You can try by changing the dimensions, for example. I don't want to do this one right now. Right? You can try, but make sure you maintain your design intentions. As you model, as you add more features, from time to time, you can verify your model is behave according to your intentions. So if you try to do these things at the end, it will be too late. It will be too late. Right? So this is the first one. Maybe most of you obviously start with this one. But you see the difference. I don't have here the fillets, the holes, nothing, just a very simple thing. So that is what you say, a simple sketch, right? But it should not always be like that. You decide whether to include your fillets, the corner fillets or the radius with the base feature, maybe or not. That is depending on your flexibility level required. So if I want to control the individual fillets, then you have 4 different fillets. If you want to control them as one feature, independent of the base, then I can have one fillet feature, then select all 4 edges. Right? So likewise, you decide the level of flexibility that you are expecting. Means in future, this is very important for something that you're going to design new. So for example, your gearbox. I still don't know the final shape, the size, and all other features. So I have to make sure that my model is flexible enough to add or remove those features at a later stage without starting from the beginning. So if it happens to you, maybe then you start several times, that means you are wasting time. So a software like this, feature-based and parametric modeling, is not meant for that. It is to support your design process, right? So the design process, you have to do many iterations, many iterative calculations due to various reasons, right? Maybe the calculation fails, the geometry fails, mean the size doesn't match with each other, or maybe it conflicts with another intention. There can be many reasons why you need to come back and then start from the beginning. So if you keep the model alive through the entire life cycle of the product, then it is very convenient for. And not only that, right? Don't think that you are always alone. Maybe in this gearbox, you are doing on your own to develop, say, skills, all the skills that is required, not sharing with others. And maybe in future, you need to work in a team, in a much bigger project. So at that time, if you start, deleting features, deleting models, and then what you had yesterday is completely different from what you have today. Locations are different, file names are different, then it will become a mess, especially for the other team members. Should not happen. If you start at the beginning, you shall discuss with the team, come out with a plan, file names, locations, and everything. So maintain until the end. Right? If you do it on your own, maybe you can control it, but not with your team members, because they don't know. Because they rely on your work, they will never call you, email you, send messages, nothing to see the latest status of the product. It should automatically happen. So you save your files in one location, maybe let's say in a cloud, whatever it is, and everyone access. So I use this part to create my model by taking some references. Right? So practice that one from the very beginning. Don't try to delete. Right? Keep as it is. When you start something, then continue with that one. So maybe I will go to the last one. Right? So that is how we generate this one. Now you see now the two major features, the base feature and the other one, connects with the object like this. Maybe that is the third feature. You see now, that is the third feature. So if I come all the way up to this, right, I'll just say, so this is again, you can see it's very simple. Can you see now? It's very simple. Why do I need this part? I need this part to connect these two. Maybe for some reason I don't want to do that one. Maybe I can suppress that one, maybe, and then I can add another one. So for example, I can create extrude on this particular plane. Right. So let me start with the wireframe thing. Maybe what do I want? I want to have something like this. I'm just drawing, right? So this is what I want. You can see over there. Where is my, let me see, it's in my other window. Let me drag it into this. Right. So you can see through all, maybe through next, right, into this side, and then finish. So if you apply the shading, this is what I want. Instead of the previous part, this is what I want. What do I need? I want to connect those two features. That's all. Right? I want to connect those two features. So that flexibility you have to maintain. I can remember those who have submitted this particular assignment, they have somehow started with the middle part. What is the logic? If you can justify why you started with the middle part with valid reason, that is okay. I'm not saying that it is completely wrong, but it all depends on your intention. Maybe you might have a different intention. If that is the case, you can start. But when you look at the object, it looks like that the middle part is used to connect the top and the bottom, which are more important than the middle one. Middle one is also important, right? And you can consider that one as a major feature, not as a minor feature, because without that, this will not function. But you should have the flexibility of modifying this, right? Or maybe if I don't like this, maybe I can say, I can suppress this, and then I can reactivate the first one again. Right? So you can in your design review meetings, you can discuss with your colleagues which one is much better, or whatever it is. You can start a thread even, and then continue getting the comments and feedbacks. Right? So that is the flexibility that we are looking for. Now one question. Now you see in the first part where this flat thing is the base feature, I don't have this hole here. Right? But if you go to the other part, you see even in the first feature, you have the hole there. Why is that? Why is that? Now, if you consider this as the base feature, actually what is the base feature here? The hole is the one base feature. Hole is the one that I'm going to use as a functional feature. But I cannot start with the hole, maybe a white space. That is why I have the outer surface as well. So there's no solution, no other way that I have to model both at once. But in the other part, this is the base feature, right? And then I can have it this one, because that's not the base feature. So that I can leisurely have my hole created at any stage of the modeling, right? So you finish your major features, then start adding your cosmetics or the minor features. Maybe you have different purposes for these things, right? Then you can leisurely add, so that you know that your structure will remain solid, right? Don't add minor features unless there is a special necessity to do so, right? So you can see all these things are considered as minor. Of course, not all are minor features. For example, the 4 holes may be important. Right now, let's see the 4 holes over here. I'll maybe this cut out over here. Maybe I will go until this point, right? Now, if you see this, for example, the fillet, you see it is over there, and then cut out is the hole is after that. So what I have done is, I have used the center of the fillet or this corner at the center of the hole. Remember, this is not small, this is slightly big. Right? So you cannot consider this one as a cosmetic feature. If I apply a fillet at this corner, this particular edge, I hope you can see the cursor, right? And then that will be a minor feature, cosmetic feature. But maybe this I need, purposely I need to put this one. And also I need to maintain the hole in the same center as this, so that this distance can be maintained. Right? But maybe this corner, I don't need this big. I can make it very small. Then it becomes a cosmetic feature or a minor feature. In that case, you have to make this hole independent of this one. Independent, what do you mean by independent? So if I change this one, for example, right? Right? So say for example, if I edit this one, this says 10 millimeters, right? So if I make it something like 15, let's see what will happen to the 4 holes. They are moving. So that means that fillet, what I've just changed the radius, is a parent for all 4 holes. Right? Design intention. That is my intention. So if your intention is something different, then you should model like that. Don't let it happen, right? But when you create features and other things, you select whatever the plane you like without thinking, and then even the relationships automatically building up without you noticing them. That way you will not get anything. Right? So please understand that you have to always concentrate on your design intention. So your dimension scheme, the feature selection, the order of features, everything need to be done with a purpose. This is especially for the ordered modeling. So synchronous modeling is different, right? Completely different from that one. You saw that one. There is no order, right? There is no order. You can delete, drag and drop to any place that you want. Nothing will happen to the other part, as long as we call the topology is not destroyed. What do you mean by topology? Say for example, this particular face, right, is connected with the 2 other vertical faces and also this cylindrical face, and there is another vertical face over there. So if I say remove this face only, then this will, like the solid will become a surface and that side will open, right? So there is no longer a solid existing. Sometimes you may not be able to close those open surfaces and everything. So that is kind of a violation of the topology, because I want to keep them like that. When you change your dimensions and other relationships, the software will maintain the topology, right? And then we have some different topics. Maybe you can even apply to this one. Again, using software, we call the topology optimization. Right? I'm not going to discuss this one here, but still you can save a lot of material, have very nice features, right? Through the topology optimization. So you keep the matter as it is, but optimize the way it is going to have it. Right? So this is the part that I gave you, synchronous modeling as well as what you call ordered modeling. Right? Oh, sorry. The taking two features as the base features. Now this is the synchronous way to do this one. You see it's over here synchronous. Right? And you can see the used cases. First one is like this. You see it is different. Right? Actually, I have already modified the sketch. Can you see? If you right click here and then you can restore it, right? So it goes above, and then if I see and click here, right click and say if you edit this sketch, right, you can edit straight away. So if you select this one, then drag it over here. I'm modifying the sketch. You see? And even I can delete this one I showed you earlier. Nothing will happen. Nothing will happen to your what you call the model. And I can even completely delete this one. Model will still be there. Model will still be there. Give me a second. Right, but still the your output is the same, similar model. Right? If you want, maybe the chamfer is the one that I created the last. Right? Let's see whether I can drag this one up. Now the chamfer is the second one. Right? You see, there is no order here. In synchronous modeling, there is no order. Right? So that's why I ask you, okay, practice your synchronous modeling once you get some good understanding of the ordered modeling. Otherwise, you get confused. But the advantage you see now, you can just do the drag and dropping of these things. Yeah, now let's say only this part. I maintain the design intention. I can drag, or maybe I can click, and even I can rotate, do many operations. You see, because I maintain the symmetry. Maybe I'll try to drag this one, for example. Maybe it's not possible this way. So I click here. Now I can select the other part. Okay, let's click here. And then through this one, I'll be able to drag this one, maybe not this surface. You select the right surface, and then you'll be able to drag this one. You see now, it's I'm moving. Right? Now, maybe I want to maintain the design intention. So if you remove that one, you might end up with a different thing. Can you see now? Because I don't want to maintain the intention. Right? Or maybe if I try to, let's say, change the plane, right? With the shift key, if you click on that lightly shaded circular plane, and then I can hold on to this one, and then I can rotate like this, right? Sometimes it fails, right? Because see, some of the things try to maintain, maybe the way I model. So the synchronous modeling, that also you have to be very careful, because in future, I mean the ordered modeling, you can always access the history, right? If you go back and then do some modifications, and you can always undo, not just the undo function, but you can go back and then edit it back to the original position. But here you don't have something like this. It's not maintaining the history. You see, the edits that I have done, only I can undo this. But if I save it and then open it again, I lose those things. I lose these things, right? So that is about the first part. And then similarly, you can try for the other parts as well, right? You can try for the other two parts as well. Practice it, and then if you have some questions, then let me know. I will answer them one by one. So today we are going to discuss some more examples, and also we're going to start or getting ready for the project, because your part is to model a gearbox with some animations, right? So how do I start the project, right? And what components will be there and so on, right? So let's say more examples. Important function even for your gearbox model, we call the pattern. You can see three different patterns over here. One is a rectangular pattern, other one is a circular pattern, even curve driven pattern, fill pattern. There are different patterns are available. A pattern is what? You copy a feature in a certain pattern on another particular feature, so that when you modify your source, right, your master feature, everything else will be automatically updated. So the difference between the first one and the second one is what? You see some of the features are missing. We call the instances, right? Suppose there is another part coming, so I should not have any holes over there. So while maintaining the pattern, I can remove those two feature instances from the pattern command or the pattern feature. Like in the second one, you can see it's like zigzag, like offset. The second row is slightly offset like this, right? Imagine if you want to create this one manually one by one, and then still you want to change it. So reduce the number of holes to, say in the bottom, you can have 4 holes. I want to make them 3 holes. What will happen? How many times or how many items that I need to go and modify? So please understand the features available in any software, and then make use of the features appropriately. Don't try to achieve this one somehow or the other method. Somehow or the other, if I can get the picture on the screen, no, that is the last thing that you should try. If you don't have anything else, again, it's only for displaying it on the monitor, nothing else. Don't practice that one, right? That way you will not be able to go far. Right? So you have to understand this one, right? And let's try this one. Maybe let's try, is there any simulation here? No, maybe I will switch to a solid edge, right? I will close these files because I don't want to load the memory. You see this, when you have multiple monitors, it always remembers the original locations and then, okay, maybe I'll start the new one, say new. Remember, this is standard templates, right? You know, you can even create template. This is what I have created. I showed you other day, right? And then this is without the base, means actually the base will not appear. It's already there. You see, base is already there, but I don't want to see that one. Let's start with a simple thing. Remember, this is ordered modeling, right? So I select this one and switch to ordered modeling. And then I create extrude. Remember, this way your sketch become what you call internal sketch, right? I hope you can remember, and you can maybe remove these snapping, snap to grid, and then grid you can turn it off so that you have the freedom to model whatever the way you want. And then make sure you apply what you call the dimensions. So make it fully defined. So I'll say this is 100, right? And then maybe I'll say this is something like 80, right? Done. And then you finish the sketch. You can maybe extrude into this direction. Maybe it's a finite extent almost. And then I'll say maybe 10 millimeters up, and then Okay, click on this side and then finish. And then you can cancel because I'm not going to extrude it again. Fine. And then I select this top surface. Again, I will create, for example, cut. Right? And then sketch on this particular plane. I just create one. Maybe you can do it under define, just the hole, right? Just the hole without any dimension. But usually you should not practice that one, especially in the ordered modeling. So I have to make sure that it is fixed. Maybe you can click on the circumference and click on the edge. It will measure the dimension. I'll do it again. Right. So click on the circumference, click on this one. Maybe if you see the dimensions, okay, I'll show you that window also. It's on a different monitor. You see why it is happening like this? My last selection is by 2 points. So Solid Edge remembers that, right? So if you see now dimension, you can change this one to horizontal and vertical, or whatever the you like, right? Horizontal and vertical. And then if you click on this one and that, then it will measure the horizontal distance. Let me say it is something like 10. And then also the same circumference and the other edge, you can see this is also 10. And maybe I'll put the diameter also as 10. So it is fully defined. You see by the color, right? And then extrude it. And then you can cut it. Maybe I'll say through all. And then this direction, fine. And finish. So let me turn off the planes so that you can see the picture. Now what do I want? I want to apply a pattern feature. Here you see the pattern. You select the pattern command, right? Select step. What you want to select? You want to select the feature. You see what else are available? You can select single, chain, a feature, or the entire body you can pattern, right? I will come to those things later. I'll select the feature. What I want to select is this one. So it is done, right? So you can say accept. And then you say the coincident plane is asking a coincident plane. You need to make a sketch. What is the sketch? The base for the pattern, how the pattern should distribute, right? So I select this top plane, right? And then you see on your what you call a ribbon, the rectangular pattern is selected. And if you see this the prompt bar, it's asking you to click for the first point, and then you can drag it and then display the other point. Sometimes by default, the circular pattern is selected. You want to create a rectangular pattern, but the circular one is selected. So then your responses will be neglected because you can't draw rectangles for circular patterns. So in that case, please switch to that one, right? And also it indicates over here. I remember I was telling this one the other day that you should have your attention, your sensors on to the entire window. Not only entire window, if you have multiple monitors, even on the other monitors as well, because any window can appear on anywhere, right? So then I will, you see all these things you can enable, right? The stagger options, I will not going to take it. You see now these things, all these things are there. So I will first select this center point. You can see it is there, and then I will just finish it somewhere there, right? But remember, this is still what you call underdefined. You see, I know that center or the distance from this edge to that corner is 10 millimeters, right? So then I will define the same thing over here as well in order to make it fully defined, right? This is 10 and also this is also 10. Now it is fully defined. Later, I will show you if I want to change 110, other one will automatically change. Relationships can also be defined among dimensions, right? So now it is finished. Then I click on the finish button. You see now it appears already over here, right? There are two options, smart and fast. I'll come to those things later. But how do I change this thing? So if I select this rectangular sketch again, then you will see now you will open some more options over here. You see over here. In X direction, that is in this direction, 3. And in Y direction also 2. Maybe I want 3 in that direction as well. or maybe in X direction I want 4, right? So that way you can control the number of items in the pattern in a rectangular manner. Or else if you go up, you see this one, I'll come to this one. Some of the things are, you can see this is the stagger option, right? So maybe it is not available for this time being. Apply it and then see all these things you can edit if you want. You can go back and edit again. Remember, I have not yet finished the target. I can finish. So you see a pattern is created, right? And if you want to pattern only, you can say the edit profile, edit definition, or you can say edit dimensions. I can change this thing. You see, I can make it again 4x4. Now you see these things are available, right? Maybe at least this one. Right. If it is available, you should be able to see that it is what you call clickable, right? Now, fit option is there, fill option is there, fixed option is there, right? You can have different options. Fill option can be found, right? You can divide sometimes depending on the depending on the scenario. Now, let me finish this one. Pattern, I forgot maybe to add something. Maybe I can just suppress, or you can say go to the other one. This is the cutout. I will have a small fillet over here, right? It's too big. I'll say something like 1 millimeter, and then preview and then finish. And then I will, you see the round is still after that one. I click or finish. And then I can unsuppress it if you want. Nothing upturned because the round is after that. I can take the round up, and then now you see the pattern has a problem, right? Now I can say an edit definition. You see the select step, features, I select this feature, and maybe both features I can select. Maybe I can say accept and then say finish. You see, that is the flexibility, right? You should understand how each and every feature is working, and then how you can control them. Then only you will be able to take the control of the modeling part. Otherwise you just try and put much effort, and still you may not be able to get the required thing that you want. So if I change the dimensions here, I'll make it say 150, for example. What will happen? Right? See whether I have violated this one or not somewhere. Maybe you see it has to be extended like this, but maybe for some reason you see it is not there. You can go back and check where I made the mistake. How about the other side? I'll make this one say 120. You see that side is working, and now still not. You see, maybe if you go and see the pattern, right? Say you see the edit profile. Now it is updated. Now it is updated. You see, according to this thing, and then you get. But right now you can see it is independent of that particular thing, right? So all these things you need to understand, right? So you go to the edit definition. You see this is fast. Maybe you can say smart. Now maybe sometimes you can't move between fast and the smart feature, so it will maintain the relationships, right? Anyway, all these things will come little by little, but I just want to show you what variations can happen if you can explore into the scenario and then try to identify why it is happening like this. That is the best way to learn, because you can't remember, you can't learn each and every step, right? Whenever you need, then you try to learn it, then it will remember. You don't want to try many times, right? Because you are looking for, you are trying to fulfill one of your requirements, right? Otherwise, if you just even go through several videos and everything, maybe you can remember that you can do it like this, but when you start doing that one, then you will face lot of difficulties. Right? So let me start a new one and then show you some circular pattern. Maybe not. Maybe I'll start something later. I'll start a new file. Again, I will. How do I stop this one and automatically get the ordered modeling as my first thing? Without noticing, if you continue, then you will continue to model the ordered features, and then later you will realize this one, right? So at the center. So if you move the mouse too fast, it won't respond that one. Depends on the quality of the mouse as well. So I'll make it something like 100 and then finish. So extrude it up to that level. Maybe I can try to have this a little bit more. I'll say something like 10 top direction and then finish and then cancel. Okay, that is the first part. Then I'll create a cut, or maybe I'll again create a extrude command. Right, coincident plane that is on this plane. Fine, and then I will create a circle again. Maybe wherever you want, you can create, right? Now I want to make a kind of a pitch circle, right? So I just create another circle. Right? Now if I define a dimension here, then what will happen? When I change the outer diameter, there will be a problem with this one. So maybe I'm trying to define this gap, for example. You see, cannot be placed. It says cannot be placed. You see whether you can do some changes over here for the dimension. I cancel this one. This is this one. You see, this is concentric diameter, all these things. And how about this? By 2 points. Let's say by 2 points. I click on this point and maybe I click on this point. Now, what do I want? I want to define the gap between the outer thing and the new circle. New circle should be somewhere here, right? Somewhere here. You say automatic, and then I will try it again. Dimension cannot be placed. See whether you have some dimensions over here. Automatic dimension, remove dimensions, you see over here. And then this is the angle between, this is the distance between, you see, symmetric diameter, and all these things are attached. You check all these things and see whether, how do I want to get the dimensions? Right? So my problem is now, if I change the outer diameter, if I increase, nothing will happen to this. If I decrease that one, this might go outside the outer diameter of the base. Right? So that is what I want to avoid. You see, even tangent dimension is over there. Maybe I can select this, I can select that. Now I can define the tangent dimension. Right? Maybe it is not straightforward. So that is why I want you to explore the thing on your own. So maybe I will keep the distance as 10. Right? Now the diameter is not defined, but only the gap is defined. Right? So then maybe I'll go to the select tool again. Remember, this is not part of my what? Feature. So I can convert this one to for construction line. Right? So this is a construction line. I use that one to create the other circle so that I can coincide with maybe somewhere here. You can start, right? Anywhere you want. And then you can define, you see here the, what do you call, the connect, not connect, right? It should be, okay, this one. I select this center point and then I click on this line. Right? Make sure that you define the relationship perfectly. Don't let it happen automatically because we never notice. But there can be many references. So I'll say this is something like 8, for example. You see, it is fully defined. Remember, I started as a solid extrusion, right? So I'll make sure that it is 5 and then enter and then finish. So let me turn off the planes. You see, it's like this. Now let's see whether we can make a circular pattern. Say it's again a feature, so I'm going to select this feature, right, and then accept. Now you see what is already selected. This is the sketch setup, and then I can select this again. Can I use that sketch? If it is an external sketch, I could have used that one also, right? But maybe I need to do it again. Okay, let's see now what is happening. This is the example. I wanted to create a circle to pattern that particular small protrusion, but by default, the rectangular feature is, or the pattern is activated, right? So it's automatically give me the rectangle option, right? So I need to go and change to circular pattern. Then I can click on the center. Then it will be a circle. Can you see? Then it will be a circle, and then it has to be on this center as well. And then this is the direction. Just in case if you don't want to make it full circle, 360. So this is the direction is going to start creating the pattern. It's going in the counterclockwise direction, right? So if your angle is 180, only the top side will be filled. So just click anywhere on this side. Now these are the steps that you have done, right? Finish. Let's finish. And then finish it over like this. So that is what you call a circular pattern. And there are many variations of that one as well. Many variations of this one as well. Circular pattern may be very important for you because you want to create many gear wheels, right? You want to create many gear wheels, and then pattern. You can create one gear tooth and then pattern around this one, right? Because you cannot create one by one. And when you create the gear wheels, of course, you can create one gear wheel and then use that one as a template and then generate all other gear wheels. Because when you want to create the gear wheel, I will show you. I mean, you need to create some relationships. We call the equations you have to define. So for each and every gear, if you start doing this one, it takes time. So you create all these things, make a model gear wheel like, and then use it, that one as a template, and then create your all other gear wheels, right? So this is for the pattern command. Maybe I will show you because it's not that critical for your modeling. Maybe I will just show you. Maybe later I will definitely help you to say the loft command. You see now you can make so many like complicated things in let's say sweep commands, right? These are some examples. I wanted to discuss this in the class, but I realized later I have only 2 hours, right? Now the maybe the difficult part for you, if the part is given something like this, how do I model? Where do I start? You see there are only 2 protrusions, and there is again you can say one is like revolve, other one is like sweep or looks like, right? This is something that we want to, that is why we want to what you call practice, right? Say let's say even this one I'm not going to open. You can see the pattern. That is another one, right? And then let's go down. These are left commands. You see all these things, right? I'll say for example a bottle. So it's empty inside. You see now it's empty inside. Now if you go to the Pathfinder, you see now if I go back and then say start like this is how you started, right? And all my sketches are what you call external sketches or internal sketches, so that you can't see that. It's built in, right? All what I had was maybe this space, you can see a kind of a sketch like thing, and also maybe there. It's a loft command. You see, this is the loft command. Right click, and if you say the edit definition, you will be able to see that one. Can you see the three sketches at three different locations? One is almost like a rectangular shape but with rounded corners, you see, and then the middle one is an elliptical shape, oval, and the top is also oval, but it's not. The major and minor axes are almost same, and then their locations are different. So if you see the top view, this is how they appear, right? They're not in the same, what you call, the vertical line. You can align them, you can, I mean, drag them if you want, right? Now, say for example, if I just select this one and then maybe drag it over there, right, then you will get the updated model. And then all what you need to do is just take the loft command from here. There's the loft command, right? Select the sections in the order, first, second, and the third, and also maybe from similar points. I mean, you should not select. You can see a small green color dot over here, right? So it behaves differently for closed curves like circles, ellipses, and also for rectangles. And you select from a similar point like this one. Don't select the other curve from somewhere away, because then your surface will be twisted, right? Surface will be twisted. You may not be able to control it. And then the other one also like this. Third one also like. You need minimum of 2. You need minimum of 2, right? Here we don't have a guide curves. Maybe if I open the other one, right? Maybe there's one more thing that I created with the guide curves. Maybe let's try. This is loft 2. Maybe let's try the bottle 2. Then we try bottle 3, for example. Maybe we have a guide curve, right? So if you go there again, you see some things are more. That is again the first part, and then I'll straight away go to edit definition. Now still, no, you can see if there are guide curves, right? There are no guide curves. Can you see here? No guide curves. But something important here, right? You see at this corner, only at the two extreme ends, you can see this particular thing. Or else you can click here. You can see over there also some additional things. Now you see, I click here, natural and normal to section, right? Now see what you have is natural. Okay, let's see now like this. If I click here and say normal to section, let's see what's going to happen. The profile started normal to section, and you can control the intensity of that one from here. You see, right? But anyway, if you visually do this, sometimes your surface or the model becomes unstable, right? Your model becomes unstable. Anyway, little by little practice those things, because our concentration should not be on these things. We will try those things actually later, right? Once you get some experience, I will give you some assignments, and also I will show you how to create those things as well. Let me show you one more thing. Sometimes you may need this thing in your gearbox. So for example, I had one thing called the handle. See whether there is a handle. Yeah. You see, this is one part. I think this is another part. This is again the loft command, right? Now you must think, okay, this is what I want. I can visualize it. I have to a certain extent, maybe these artistic skills and everything, or maybe in my team, one member is very good at arts and other things. So he's going to visualize, okay, your handle should be like this, very nice aesthetic shape or whatever it is. Then he's going to create a sketch for me. Okay, create a handle like this. Then how should I start modeling this one? I know extrude command, I know revolve command, all these, with the parametric, the what do you call this, analytical curves. I can get those shapes. If you think in the mechanical engineering line, you will end up with things like shafts, cylinders, the disc boxes and everything like that. but you should go away from that one as well, and then come out with some things as well. And not only that, it has to be symmetrical, and more importantly, your thing should be manufacturable. It's very important for the mechanical engineering. Okay, we'll come to those things later. But remember, these things are possible. If anybody wants, you can try and get some experience before that. So this is what I'm showing here. You see the gear wheel and the pattern, right? So for example, for a gear wheel, right? For the gear wheel, I hope I have created one demonstration one. See whether you can find some opinion. Let's maybe like this. Right? Very simple. Yeah. Of course, there is a built-in parts library also in Solid Edge. I think I remember one student asked from me, but my advice is don't use them at the beginning, because then you can't practice or learn Solid Edge. Try to use your knowledge and then build all these things. Then later you can use the built-in library and other things. So let's see here. You see now ordered, then simplicity, I'll come to those things later. This is the base. What is the base? If I right click and say go to, I can suppress up to this one. It's a very simple thing, right? Very simple disk-like thing. And then there is a cutout. You see, that is the hole. Maybe I can activate that one as well. That is where the shaft will come. So initially, this is also enough for you to continue your design work. Your design calculation may be not yet finished or maybe not yet finalized. Thickness can be changed. The diameter can be changed. The inner diameter can be changed. So you leave some options. Now, when you start like this, these are the base features. I know that I can change the diameter, then others will follow this. I will show you some things here, right? Because it looks okay. Then there is extrude command. What is that extrude command? Actually, it's a surface. You see here, that is a pitch circle, right? Because you can model this one in different ways, right? And then your final, the output looks the same, but it will not serve your purpose. Maybe I'll hide it, and then let's see what I have generated. You see, using that pitch circle or the pitch surface, I have created one gear tooth, right? One gear tooth. Of course, this has to be an involute shape, but maybe if you can get approximate shape, that is good enough. The reason is you are not going to use the references in your model, 3D model, to cut the gears. Gear cutting are different procedures. I mean, you have the module cutters, you have rack and thing. There are different ways to cut the gear teeth, right? So that reason you don't want to make the, if you want, you can still do that one, but it's just a circular arc. Let's go and check edit the sketch. This is the edit profile. You see, maybe I'll try to do this one like this. It is like this. You see what I have done something wrong. I have joined them straight. Can you see here? These things should not happen. Although it is, and then it is like this. I'm going to maybe create a loft sweep, or you can even extrude, whatever it is, right? But there are many advantages and disadvantages of these things as well. But anyway, you see, when I do this, nobody will see how I have modeled the thing. Then I will add the pattern as well. Fine, I get everything correct, right? For gear wheel, so this should be your starting point, and then add other things later. Okay, now what is next? I hope you can see the gear wheel, right? Maybe I'll just cancel these two, right? Now I want to change the, say for example, what? The diameter, right? This is where the diameter comes, right? I'll change the diameter. What is this one? It says the dynamic edit. This is now 52.57. I don't know why I put 52.57. Let's say maybe it is so there's the base circle, right? So maybe I'll make it something like, how much is that? 52. I'll make it 55 or 56. You see what has happened? Now that profile is no longer there. Can you see now? Where is that root? Maybe I'll undo once. You can observe this. You see the two fillets at the corner, now they are missing, right? Now they are missing. Means my gear, the model is not updating accordingly, right? I'll undo this, and next time maybe I'll reduce the diameter, right? I'll reduce the diameter. So earlier it was 52.5, maybe I'll make it something like 50. Let's see what will happen. You see, there's a separation right now. Means the model is not failed. You see, even the what do you call this pathfinder, nothing is failed. Nothing is failed. Everything is fine. But this is not acceptable. You know that, right? This is not acceptable. This is not a gear wheel. So don't model like this, right? Again, this is part of your visual modeling, right? Or else maybe I'll undo this again. Undo this again. Okay, maybe I'll redo once, and then change the what do you call the number of things. For example, just select this one, right? You can change the number of items, say the total number of teeth. It says 20, right? I will make it 15. See whether you can do it 15. Or maybe I can, I don't know whether I can make it 15 or what is the minimum number of teeth. But anyway, solid edge is not checking all these things. Can make it 15. Can you call this one a gear wheel? You cannot. You see the gear tooth is a small, and then the space between two gear teeth, this is large. We have a huge backlash, right? How about the pinion? If it is the gear, and if how about the pinion? Pinion will have a different dimensions, right? That's not going to work. But what will happen if I increase the number of things? So it was like 20, right? I'll make it like 24. Now what happened? Maybe I'll make it even like 26. Again, can you call this one a gear wheel? Now you cannot. So this is where we need to learn how to model this one so that you can update your model. Maybe I have another one. I'll show you. See whether there is another gear wheel open. Maybe this one. Right? I'll try this. I'll get the front view. Say let's go back to your sketch. The protrusion is over here. I'll come all the way up to this. Almost the same, right? Almost the same. And then sketch, and then I'll say I have a cutout here. What is that? Earlier it's a protrusion. Now this time it is a cutout. You can do both ways, right? You can do both ways. But if you open this cutout and then see, this is a sketch for that one. You see now, if I edit the sketch, say edit profile, you see there are many things that I have got here. Why? Because I want to manipulate this thing. I want to manipulate. I'm not going to go to the details at this time. Right? I will finish that one. Right? And then finish this one. And then I will activate the pattern. You see now the pattern is over there. And then I will hide the sketch. Right? Let's try to change this one. Let's say, for example, let's try to change the diameter, see whether anything is happening. The thickness, you see the diameter is not appearing over here, right? And then let's try to change the, what do you call, the pattern. So I'll try to edit the pattern, select this, at least it is open there. This says 46. Can I make it like 50? Can you? You can't. 46. Still 46. Now it is fixed. Why it is fixed? Because it is being controlled but not by just the visual thing. If you go to tools and then the variables, okay, the window appears in the other monitor. This is how it looks. Right? So this is why I told you it's not easy to give you everything in 1 or 2 lectures. Right? So everything is related, and then you can see I have given some relations also. Right? So I can change that model only through this one, right? So maybe I will keep it like this. Maybe I'll make 46 to say 40, right? Let's try. It's changing. Have you seen that even the diameter got reduced? Right? Or maybe I'll make it something like 25, right? Just observe. You see, still the shape and everything remains the same, right? Still remains the same. I'll increase it again. Maybe I'll say 40 at once so that you can see a huge change. You can see the number of teeth. Now this is 20, 25, I remember. Now it is 40. Right? But they are related. Remember the number of teeth, the diameter, the module and everything are related. Right? So if you can use these equations and then build those things to the model, then the model can be very nicely controlled. Remember, still I haven't gone through the other features. Still I haven't gone through the other features. This is what we call the variables in SolidWorks, which is equations, right? Equations. So we should know how to model these things, right? And then if I go down and then see how many other things that I have added, you see, everything else is after that. Everything else is after that. So in ordered modeling, you can control them much more conveniently for your gearbox because you are still learning. Because you are still learning, right? Okay, so with that, these are the things that we need to practice, right? Some more bottles like this, handles like this, you can see. I'm showing to see whether you can do all these things. Any questions? It's actually your effort, right? Remember, I can show you the path and it is your effort that will take you to the destination that you want. If you want to learn and practice and become at least a little master of solid edge, then you follow these things and practice, right? So let's start. Now I've shown you some what you call images of the gearboxes. It's complicated inside, right? You have so many parts. At the end, you should be able to put all these parts together, assemble into a gearbox, put the house in, and then when you connect with the prime mover, it should function. Right? So when you say you design it, and then when you machine, sometimes you can't assemble it. Or the way you have machine, you can't fix the locations. There will be thousands of problems coming. Right? So my part is to give you some of them so that you can start your design work. Now this is the gearbox housing. Right? It's complicated as it is. One, maybe the one on the top left hand corner, maybe for a vehicle, for example. Because the gearbox, you need to be mounted somewhere. In a vehicle, it is different from a industrial gearbox where I'm going to fit inside a factory. Right? You see the different sort of housings, from some simple housings to complex housings. Some are split, like for example, one on the left hand side, the middle one, and then one in the exact middle, they are what you call the split housing. Right? That whereas the vehicle one, it is not split from the middle. It is a different sort of configuration. And one in the bottom left hand corner, the motor is straight away directly mounted to the gearbox. So motor shaft, you can take it as what you call your input shaft. Right? You have such motors, we call the flange motors. So you should see the available options for your gearbox. And then one on the right hand side, the blue color one, you can see the shafts are at an angle. And even the one in the bottom, shafts are at an angle. So what does that mean? You need to use maybe a bevel gear mechanism, or maybe the what do you call this, the other type, worm and wheel type, right? So if you want to change the direction, maybe not 90 degrees, sometimes maybe a different angle. First, explore the possibilities. So then it will help your design thinking part. But without doing all these things, don't come out with what you call simple box shaped things, because you are not going to learn anything. You can't show that one to somebody else, right? This is the gearbox housing. And this is what I have modeled last week together with the students. And this is the final model that I'm showing you. I went through almost all the steps, not of course in much more details. You can see there are many things over here, right? And if I see the housing only and the parts, you can say still there are large number of components inside. So you should be able to manage all these things, right? Remember, now in your gearbox also you might have this many of what you call the components are there, right? All these gear wheels should be able to mount on the gear, the wheels, the shafts, and everything together. You should be able to mount on the gearbox housing, and then gearbox housing you should be able to machine or manufacture, right? And you should have these end caps, seals, bearings, inspection holes. You can see even at the bottom the oil hole, oil drain if you want to take the oil out, and the shifting lever, the mechanisms, and then the inspection holes, gear shifting, everything need to be there. Everything need to be there, right? So if you start in a simple manner, then you can add those things later. Add these things later, right? So this is the exploded view, and this is the housing, right? Only the housing, and then the gear wheel, for example, maybe I think this is the output shaft. You can see on that one you have several things. And if I take, of course, the red color one is to show the animation, otherwise there is no purpose. So if I show you the exploded view of the shaft, you can see there are many components coming in a particular order. The shaft is not one straight shaft. There are many steps, so that you should be able to insert your gear wheels from one side or maybe from both sides. And then also the bearing. You can see those two shiny surfaces are the bearing surfaces. And you can see the left hand side of the shaft is bigger and the bearing is little bit inside, right? And that bearing is bigger than one on the right hand side, because that I should be able to bring the bearing all the way to this point. Otherwise you won't be able to do that, right? And then if you take the shaft alone, this is the spline shaft. I mean, those details are available, but maybe not as you want. So you decide, how do I put them, and then how do I manufacture them? I should be able to machine them. I should be able to take the dimensions out of that one. And at the end, you should satisfy your design calculations as well. So for example, the minimum shaft diameter, right? And I've seen many students. So for example, here you have the spline shaft, the bearing diameter. So the bearing diameter, like you can see, I can take the bearing from the left hand side because it is bigger. The step is to stop the bearing. Otherwise, when you assemble, there's no reference. Someone who is assembling should know exactly, push the bearing to a corner and then it hits on something. Okay, that is the point that I want to stop. Right? You should have all these things. And in this case, because the bearing should come all the way from the right hand side. If this spline shaft diameter and the bearing inner diameter is the same, you won't be able to do that, right? You're damaging either the spline shaft, or if you do it many times, even you can damage the bearing because someone needs to hammer this one. So that means this should be small, slightly smaller, right? And then select the bearing. So maybe if the spline shaft is a standard spline, whatever it is, so the diameter is fixed. And if you do the calculations for the bearing, the available bearing is maybe the same. So definitely I can't use that. Then I need to go for the bigger bearing. So that means this end of the shaft will become bigger. So if you continue like this, you can see you will definitely have a step shaft. We call this is the step shaft. And maybe you can go back and then check for the strength, the bending, for example. And then there are many other things coming up which will increase the, what do you call, the stress concentrations. Maybe you have not calculated those things. You are not accommodated for this thing because you were thinking one straight shaft. So you have to go back and change the calculations. When you do the calculation, you can see sometimes somewhere it's going to fail. You need to check the deflection of the shaft, because when the gear wheels are mounted, if it is deflecting too much, then it's not good. It will create vibration, shattering, and everything. Right. So this is about the shaft, and this the input shaft. You can see over there the two bearings. Now I can fit from two sides. You can see the two different shades are there. Right. And these steps I can use to locate the gear wheels. Remember, inside the gearbox, I need to locate them exactly. How do I do that? I can't just take a scale, measure the distance, and fix the gear wheel. Once this gearbox started, it will move here and there. It will move here and there, right? You see, this is the what you call the dog clutch. It depends on what sort of a mechanism that you use to shift gears. Right? All these things need to match. Sometimes you do these things at the end, right? And when you try to add material and develop this thing, you realize that it is not enough. So you go and increase this one. Sometimes it might go and clash with another component. Right? Always expect modifications of the gearbox. Right? So leave some time for that. Leave some time for that. Otherwise, you won't be able to do that one. So I'm going to start with the shaft actually. I mean the gear wheel. Right? Like this. You see, these are the gear wheel. You can see this is a different gear wheel. Right? This is a different gear wheel. You can add all these the minor things once you satisfy the basic requirements. Some standard components, the bearings, the snap ring, right? Internal and external, they are two different sides. These are standard. You can see the sizes except in the one second from the right hand side. And the last one is just a bush to space out the gear wheels with one another, right? All these parts you need to design and model. And then the end caps, nuts, bolts, the shifting arm or whatever it is, including the shifting lever. These things are not like, for example, except for the end caps, and even end caps sometimes you have to design on your own. One on the top left hand corner is the end cap that comes to the input shaft. Shaft should be taken out, right? And you see it is with a certain depth, not like one in the middle. And then there you should have a seal. Sometimes when you look for the seal, the seals are standard. The outer diameter of the seal is much bigger. When you try to match with your shaft diameter, outer diameter is much bigger. So if you try to, enlarge the outer diameter, sometimes, yes, for example, these two end caps are coming one after the other. So one diameter increases. Let me show you here. All right. So it will be like this. This is one, and then other one is like this. For some reason, if you want to increase the two diameters without changing the center distances, right, it might look like this. And then other one might look like this. Maybe it might clash if it is in the worst case like this. So then you have to go back and change. Right? So believe me, if you can do it at once, you are lucky. Lucky in the sense, time-wise. But maybe the learning-wise, maybe you are not lucky. Because you don't get that experience. You don't get that experience of going through difficult situations and then practicing for different conditions. Right? So these things will happen. Don't take it easy, and also don't make it too complicated as well. No? Right. To show you some of the gearboxes from your previous batch. So this is one of the best, right? I have shown only some of the things, and the best one I can't open in my office, right? So this is one of the best. You see now he has followed my instructions. You don't want to follow my instructions, but if you can come out with something acceptable, reasonable, that's good enough. Right? You can see even the flanges are there. I hope I can maybe zoom this one and maybe show. Right? You see a little bit. Right? And even the flanges for the gearbox housing, everything is there. Right? There was even a much better this one than that. I'll tell you, it was a kind of a in-person class, physical class inside. During my last few lectures, last few weeks, first few weeks it was packed. The last few weeks only, maybe I think around 10 or 15. I didn't stop, I continued. So these students are from those 10, right? And I'll show you what happened to the others. This is again one of the outputs. You have the gearbox and the gearbox cover, but there are no bolts to connect. You see how it's going to happen here? Right? Maybe I'll use the pointer at least. Where is the pointer? You see over here? What is this? You see the shaft, how it is coming out? You see over here? How do you machine this? How do you manufacture this? Look at the inside the gearbox. Look at the gear wheels. Look at how the bearing is mounted. It's totally unacceptable. Totally unacceptable. Right? So please realize this, right? I mean, how can you take this one and show it to someone else and the other one? Look at all the gear wheels. Look at how it's used to manage. Remember, you are assembling a gearbox, right? Wheels mounted on the shafts and everything together. You have to make sure perfect alignment is there. Otherwise, you don't. How do I get the perfect alignment? I need to machine perfectly. So how do I machine perfectly if there are many parts? Look at and the middle one. This is inside. There is a small like thing, eye bolt like thing. This part is inside. How do I machine that part from the other side? Of course, you can cast it, but look at how complicated. Right? And then this is again something. To my experience, except for the gear wheels, even the gear wheels, if you make one, you can copy and then modify the other one. Do you think that it takes many weeks? Yes, it will take many weeks if you are not going to practice. Definitely it will happen. Why should you? If you can learn this one leisurely and then get to a very acceptable level, right? So that is what we expect from you, right? We are trying our best to help you, right? So try to understand this, right? You see now. Now this is another one. We don't know whether the mechanisms are working or not. There's no way that you're going to mount. You can see the shift in mechanisms, the green color, the blue color, the shafts. I don't know how do you going to mount that one. And you see this, the caps are not there. Is something like copying from the one of the previous. I wanted to show you that one as well, right? Means you don't have your own idea. I mean, you can't take the ownership for this one. You can't take the ownership for this one. And then you have this the gearbox, what you call mounting legs and everything like that. Right? Look at one on this side, one on the other side. Right? These are actually very critical things. Right? These are actually very critical things. Right? So this is the guideline that I gave you. So where do I start? I have given you some images, and of course I have demonstrated it at the beginning of the class, how you should concentrate on these things. Maybe initially you don't want to concentrate even on modeling the gear tooth, or maybe the entire thing. You can just keep one tooth model and then leave it as it is, because you can save time. Patterning is not a difficult part, right? Patterning is not a difficult part. So you have to, before you patterning, then you have to start how to create one gear tooth that can vary by changing the parameters, the module, the number of teeth, right? The gear pitch circle diameter. All these things, if you can change, it should automatically update. So if you can get up to that level, pattern, you can leave it at the end. Pattern, you can leave it at the end, right? So I request you to use ordered modeling, right? Synchronous modeling is possible, but it will not give you that, what you call kind of relationships you can't build up, right? So you might find it difficult, right? And represent the gears as simple disk initially. That is good enough, right? And model one gear tooth, that's also good enough, right? Not necessary to model with the involute profile. If you can, maybe if you have time, we will even try out that one, and then pattern and get the rest of the teeth. This is where I'm going to start. Shafts are simple, right? So you need to decide how I'm going to model the shaft. Shafts are in steps, not in one. So if you model the entire shaft as a one cylindrical part, and then how do I going to get the steps? The steps, the distances can be vary, the diameters can vary, right? So you have to keep, them independent as well, because your requirements can change. Requirements can change, right? So maybe this is all what I have to say. Maybe I will go to the solid edge again. Right. So let me show you. So for example, how do I use some equations, right? Let's try simple thing. Simple thing first, and then you practice, and then you get this one. So maybe remember, I need to have an ordered modeling, right? I click and then say ordered modeling. Then I'm going to create, maybe you can create an external sketch or maybe an internal sketch. In ordered modeling, that's not going to be the case. Only thing, if you have external sketches, you can see them in the Pathfinder, which will be sometimes very ambiguous to see the thing, right? Anyway, I will make an internal sketch. I want to have an extrude one, and then select this one here, right? And then create this, just a rectangle, very simple, right? And then apply the dimension here. I'll make it 100, right? And then also I'll make it say something like 80. Those things I know that I can change, right? I'll go to the select button, and if I double click here, you see it's going to open what you call the variable definition. The solid edge has automatically given the variable name V475, right? So if I have say 100 different dimensions, V75, and then different numbers, I may not be able to recognize what it is, right? Maybe I just put this, right? So I will change this one. For example, I'll say this is base length, for example. Practice from the very beginning, right? Base length. At the moment, there is no formula. If you want, you can type any comments, right? So for example, you can put, don't increase the length beyond 120 millimeters, or don't reduce it below 80 millimeters, or some kind sort of a message you can put, right? Not big one, but small one, right? So then apply this. Again, if you double click this one, I'll be able to see the base length, right? And then how about the other one? Other one still have a V476, right? I'll finish. Right? And then I will exit the sketch, and then extrude, maybe say something like 15, and on to top side, and then finish and cancel. Right? So if I turn off the reference planes and then double click on this, and then you have, where is the height, somewhere here, you can see. If you double click again, you can see it's given a different name by the solid edge. You see, extruded protrusion or something like this. Maybe I don't want that one. I want to say height, for example, and then apply. Okay, so that is 15 for the at the time being. Now, if I want to make this length and the width equal, How many methods are available? How many methods are available? I can make the two dimensions equal. I put 100 into one, other one also 100. Or I can open the sketch and then say length of select the line, and then that line is equal to the other line. So then you don't want to dimension also, right? But if I want to tell the software that I want the length of this one, say, or maybe the width of this particular plate is 1/3 of the length, or maybe 2/3 of the length. Some sort of a mathematical relationship. That way I will not be able to use the constraints or the relations. For that, I have to access what we call the equation. So if you go to tools and then you have the variables over here, click here. You see you have the variables. Again, there's a lot that you need to learn here. So this is about the protrusion, and you can see now that base length appears here, height also appears here. That V476 is the name given by the solid edge. Right? And look at that, the base length and V476 diameters are locked. Right? I'll come to that locked dimension and unlocked dimension. What does it mean in the ordered modeling? Right? Even here you can see this one. Now you can see the formula, for example, here. Now this is locked, right? Say, can I say this one? Say, for example, I'm going to put the equation here, right? So, for example, equals, say, the base length. Is that the base length, right? I'm trying to do this one. I'm going to use simple letters, see whether it's going to work. Say, into, or maybe say divided by, okay, maybe say into 2 and then divided by 3. Right? See whether it's going to work. You see, it automatically calculated, but look at that lock sign, it's disappeared. Lock sign is disappeared. Right? And of course, you can have your own thing over here. For example, this is a user variables. Right? I can maybe define one if you want over here. Say, for example, I want to say, for example, maybe I want to add maximum depth or maximum length or whatever it is. Right? I can sort it, I can filter it, I can have different formulas as well. You see, there are variable rules as well. You can get the printout of this thing, otherwise you can't see that. Right? So if you have this, so for example, I'll say max length here. I'll say here, say max length is say 120. Right? In millimeters, it automatically took the max length to the millimeters. Maybe I should be able to write some relationships over here. Right? I'm not going to put everything on you today. Right? You can see there are a lot of things that you can see. Value based, formula based. I mean even the link formula, you can try to apply the formula. The more maths and trigonometry, you can see there are a lot, right? There are a lot that you can see, even the logical, right? Even the logical, right? All these things can be built into the thing. Or you can say you can limit the value. Maybe I remove this, limit the value. Okay, discrete list. Or you say the maximum and the minimum. You see the maximum greater than, less than, right? Greater than, or maybe if it is a maximum, should be greater than or equal. Right? All these things you can modify. And then here less than, maybe I'll say here none, and then say less than, I'll say variable. Of course you can get the variable, and of course you can say the value here. I'll say something like 120, or you can say the max length here. Right? All these things you can apply here. Right? There's a limit for this one. Right? So that way you can control the interface very nicely, so that you know that nothing will go beyond your what you call notice. That is what I want to have this in the model. So you can close it. Now you can double click and see, and then you see the color here 100. This is in a different color, indicates that I cannot change this one. Now this has become a driven variable. This is a driving variable. Remember, this is 2/3, right? I'll make it say 120, right? Don't double click. Just click here, then say 120. Let's see what's going to happen. You see, maximum not value, right? I'll make it something like 60, for example, is applicable, right? Or even 119, it should work. 119 it should, because I put less than 120, not less than or equal. So that way you can control how you're going to have it. Say the gear wheels, right? Sometimes you have the shaft diameter and then the outer hub diameter. So you can say the hub diameter should always be greater than the shaft diameter. And then shaft diameter of the gear wheel, you can equate that one to the shaft diameter of the, the gear wheel hub diameter and the shaft diameter, you can write some relationships. So that if you change one, other one will automatically update. It's actually a lot, but I don't expect you to go through all these and make it fully automate. At least one or two functions that you apply there, then you know that it is possible, right? It is possible. So later, definitely knowing that I have done this once, with that confidence, you'll be able to learn more when the time comes, right? Try to learn as much as possible. When you are in the university, we can help you. Maybe when you go out, there is no one to support you, right? There is no one to support you. You are on your own. So if you want to maybe just show your experience and the skills once you go to the industry, this is the right time for you to learn. These are the software and other things you are straight away used in the industry, right? From the day one, you can give some productive output if you know these things, right? Although in our country, the design is not that prominent, we're not doing designs, but in future, you may need it. Or even if you, as planned, you want to go abroad, yes, who knows? These are some very valuable skills, Learn them, right? I was actually, I don't know, how do I say, don't misunderstand, right? When you were complaining about, maybe not complaining, but just telling of you had too much of workload, I was wondering why, because you saw the result, right? The last year's result. You see all these things, right? At that time, we could not help the students by going through only a small number. We could not, check their models continuously from time to time, their steps. And we had time only during the last, what you call the Viva and the presentations. At that time, it is too late. So that is why we decided, okay, we will have, so for you monitor continuously without burdening you. Actually, we are not giving you too much of work. We ask you to work and then show us. That's all, right? So that we know that you are in the right path. Then you know that you are not getting into the trouble at the last minute, and then you can learn. Not just you complete the assignment or the project and then finish it off, right? Because the time is valuable. The effort that you put, there should be a gain at the end. Right? Yeah, if it's still anybody wants, you can come and meet us, right? Although we are not going to have a regular thing, right? We will always there for you to help and then to improve your, what you call, the knowledge and the skills on all these things, right? And there was a question that I could not ask you here. The red color thing. What are the possible issues that may arise in the future? I'm talking of only the gear wheel. I showed you some of them, right? Based on your design, you have to change the diameter, number of teeth, maybe the module, the shaft diameter, right? What else? If you can predict what would happen in the future, then you can be prepared for that today. If not, if it all unexpected and your model is not flexible enough, then you will struggle. You will feel the pain actually. It's difficult. Right? So keep everything in an orderly manner. Right? Orderly. Don't think that this is too much of work, but this is, I would say, I mean, not I mean, extraordinary work. This is normal. If you can practice, you should be able to do that. Yes. Can someone tell me what else you would expect? What other changes you would expect? Diameter is one, number of teeth is one more, and then module, maybe the shaft diameter. What else? What else? No idea. So if you can think of the future possible changes, right, then you will make your model flexible, or else you will not model until the final stage. So you know that I'm going to modify this one anyway after that. Adding all these, I said earlier, the minor features. Remember, there are no minor features as such in synchronous modeling, right? It's only in the ordered modeling because there is an order. Major should first and then the minor should come next. And also you should have some idea about the maximum, or I'm sorry, the minimum number of teeth that you can have. You have two standard pressure angles, 20, and another one is I think 14.5. Right? And also the maximum gear reduction, or even a step up. Right? Can I get something like 1 to say 75, 80, or even 100? Right? All these things you need to check. These are there are recommended values as well. And the other day I remember Dr. Dilshan asked you the gear ratio. Can you make it all integers? You can make, initially you can assume like this, right? But anyway, finally, what would be the factor that will decide the gear ratio? Is the number of teeth, right? Say Z1 over Z2. But initially you calculate the gear ratio maybe based on the speed. You know the motor speed, you know the output speed, the required speed. So you then divide, then you can get some values. But based on that, then you calculate the number of gear teeth. The number of gear teeth cannot be like say 24.5, 24.6 or something like this. It has to be an integer. Both the pinion and the wheel. So final gear ratio, you need to calculate from the number of teeth. Right? So if there are, say for example, many wheels mounted between two shafts, right? So let's say this is one shaft is like this, and then there is another shaft where the cursor. Okay, right. So my values are different color. So this is one gear mesh, right? And then the other gear mesh should come like this, right? Maybe another one over here. I'll make it a little bigger. And then the other one would come like this. Only two, right? I'm going to show you only two. So if you calculate the center distance by taking this mesh or this pair, it has to be the same, exactly the same if you calculate from the other one as well. Right? Otherwise, the two shafts cannot be in parallel. You have to check all these things. Maybe you don't calculate, but you need to check. For some reason, if it is changing, so that's why I either use the MATLAB or maybe Excel, so that you can see whether this is going to violate. And you can put some conditions. So for example, if it violates, then you can highlight that particular cell in red color. So at a glance, you go there, you see that one. Those are additional, but the effort is worth. Right? First time you have to put some effort, second, third time, and then you can repeat the gearbox calculations maybe even 10 times, 20 times without any effort. Right? That experience is very valuable for future design projects as well. Right. So next week I'm going to show you, I don't know whether it is next week, I think next week, a gear wheel, and then how simple gear wheel, and then how to use the equations, and then try to maintain the relationship so that when I change the diameter, the number of teeth, the gear will automatically update. And then I will take a copy of that one and then create a gear pair, a mesh, and then show with a small animation how you're going to maintain, then how you're going to check that one. Right? Then you will realize that you don't need the gear teeth in order to make a gear mesh. You can define the gear ratio and then the solid will automatically animate that one. But anyway, so the next week our discussion would be that. So please try to find out some information so that maybe you can even try on your own. So it will be helpful. Right. Any questions? Any questions? No? Okay, so then we'll wind up for today. I think we have the class tomorrow also. Right? So definitely we will concentrate on the image. So keep all these things in mind. Don't postpone your work for tomorrow. Tomorrow maybe you don't have time, right? And don't make it as a burden also. Maybe whenever you have, say, leisure time, you can enjoy this one by modeling, right? By modeling. You are still young, right? I'm maybe too old to do this. I'm still doing this because of the interest. If you create that interest, you can't stop. Right? Then you will never complain. Okay, then. Thank you.